Important topic, Foster-Seeley Discriminator. అంటే ఏంటో తెలుసుకుందాం. యాక్చువల్గా ఏంటంటే ఇది మెయిన్గా రేడియో రిసీవర్స్లో యూటిలైజ్ చేస్తాం. ఎఫ్ఎం రేడియో రిసీవర్స్లో ఇది 1936లో దీన్ని ఎస్టాబ్లిష్ చేశారు. ఎంటైర్ Foster-Seeley discriminator అంటే నథింగ్ బట్ ఇట్ ఈస్ యూజ్ టు కన్వర్ట్ ఫ్రీక్వెన్సీ వేరియేషన్స్ ఇంటూ amplitude వేరియేషన్స్. ఓకే, దీంట్లో బేసిక్గా కాంపోనెంట్స్ ఏం కావాలి అంటే నథింగ్ బట్ ఏంటంటే ఒక ఆర్ఎఫ్సి చోక్ ఒకటి, ఒక సెంటర్ ట్యాప్ ట్రాన్స్ఫార్మర్ ఒకటి, ఒక కెపాసిటర్స్ ఒకటి, యాజ్ వెల్ యాజ్ ఒక రెసిస్టర్స్ ఒకటి. దీనికి యాక్చువల్గా కన్స్ట్రక్షన్ కావాలి. ఎంటైర్ ఆర్ఎఫ్సి చోక్ అంటే నథింగ్ బట్ ఏంటి అంటే ఇట్ ఈస్ యూజ్ టు రిజెక్ట్ హై ఫ్రీక్వెన్సీ కాంపోనెంట్స్ ఆఫ్ లైక్ ఆర్ఎఫ్ సిగ్నల్స్ ఆర్ ఏసీ ఇంటూ అండ్ అలో ఓన్లీ లో ఫ్రీక్వెన్సీ డీసీ సిగ్నల్. ఓకే, ఇప్పుడు మన ఎంటైర్ దీంట్లో ఏంటంటే it is used for to achieve good linearity at the output. At a time it is used to provide high output than that of ratio detector. Okay, it is high cost because of transformer, and it is allow narrow bandwidth. Okay, in this it is also known as FM demodulator circuit. What is meant by demodulator already know. Nothing but demodulation means it is the process of extracting the original signal from the modulated wave. Okay, entire Foster-Seeley discriminator are also be known as phase discriminator or center tuned discriminator. Okay, let's go into the topic. In this we are using you are setting 3 modes. Before that nothing but at resonance the output voltage is 0 because the potential differences applied across diodes is 0 and diodes are equal. Above resonance means in this the circuit used to provide an output voltage as positive. Below resonance means the circuit provide an output voltage is negative. And FMs in this the block diagram actually look like in this the FM signal is given as input. A capacitor has been taken that is known as C1 and CP. Another transformer. This 2 diodes have been connected like this. Again we are placing 2 capacitors. Another one is we are placing 2 resistors. Measuring output like this. Actual block diagram look like this. In this the center tap is RFC nothing but choke. Okay, in this we are again operating in 3 modes: mode 1, mode 2, another one is mode 3. In mode 1 the input frequency is equal to center frequency, both the diodes D1 D2 are equal, so that the output voltage is 0. Whereas in mode 2, the input frequency is greater than center frequency, so that in this the vector sum of both diodes, the upper diode lag more voltage than that of lower diode D1. Okay, so that the C3 and C4 capacitors are used to provide a maximum voltage, that is positive. Whereas in if input frequency is less than center frequency Fc, in this the vector sum upper diode will conduct less than that of lower diode. In this, C3 C4 is used to allow a negative voltage at the output. Okay, the mode 1 acts as a resistive circuit, and mode 2 can be acts as capacitor circuit. Nothing but tuned circuit can be act as a resistor, capacitor, and the last one is inductive circuit. Okay, its famous application is it may be used in FM radio receivers. Another one is it's having a phasor diagram. Nothing but phase diagram. Phasor diagram means it is used to represent the magnitude and phase in terms of vector. Like this, in first both the diodes are being equal, so that at resonance condition V1 V2 are having a 90 degrees angle, whereas in Fi is greater than Fc, in this V2 is having a higher voltage than that of V1, whereas in that is Fn is less than Fc, Fn input frequency is less than center frequency, input frequency is equal to center frequency. In this, it is used to provide a 90 degrees plus theta degrees, 90 degrees minus theta, whereas it is used to provide 90 degrees plus theta degrees. Okay, these are a basic observation in Foster-Seeley discriminator. Okay, another one is ratio detector. Ratio detector means it's a simply another construction of Foster-Seeley. In Foster-Seeley we are having nothing but we required another circuit, that is limiter circuit. What is meant by limiter circuit means it is used to reduce amplitude variations as well as amplitude noise. For that there is the required limiter circuit. Okay, next one is ratio detector. Ratio detector means in this the 80% of the circuit is same as Foster-Seeley, only nothing but we are adding an load capacitor that is used to hold a total diode voltage, diode DC voltage at the output as constant. Okay, so that a load capacitor is been at the circuit. Okay, it is a ratio detector. Ratio detector means we are using nothing but 3 wire windings, that is primary, another one is secondary, another one is tertiary, that is 3 winding. Nothing but in this 3 wound transformers are being used. That's why its circuit is complex. whereas Foster-Seeley it is a simple in construction. Whereas ratio detector it been complex. Again in this three modes, Fin is equal to Fc, Fin is greater than Fc, Fin is less than Fc. Okay, three modes like this. In this both the diodes are been equal, so that having same potential, so that the output voltage is 0, whereas in this the input signal of D1 is exceeds that of D2 voltage, so that V1 increase the voltage plus V1 plus delta V, and V2 decrease the voltage minus V2 minus delta V. Therefore output voltage can be written as V0 is equal to minus delta V. Whereas in Fin is less than Fn, in this the input D1 is less than D2, so that V1 is used to decrease the voltage V1 minus delta V, whereas V2 is increase the voltage V2 plus delta V. Therefore output can be written as V0 is equal to delta V. Nothing but in this ratio detector V0 is equal to 1 by 2 of VD1 plus VD2. It is the half of the voltage of two diodes. Okay. This is about ratio detector. In this, the amplitude limiter circuit has been used in this inbuilt circuit, so that it is easily remove amplitude noise. Okay, that's about Foster-Seeley discriminator. Okay, that's in between Foster-Seeley and ratio detector they be common. That is, what are their, I used to tell, basic differences. Nothing but Foster-Seeley as well as a ratio detector. Okay, in these two diodes are being used, D1 and D2, whereas in this two diodes are being used, the D2 is in reversed condition and one diode is been reversed. Like that it's actually look like in Foster-Seeley, whereas in ratio detector the diode has been reversed. In this it require amplitude limiter circuit. It does not require amplitude limiter circuit. Okay, in this the voltage are being measured across resistors R3 and R4. In this the output voltage is measured at different points, like that I used to draw the simple diagram. At the output stage I am drawing of ratio detector. In between this is C3 and C4, and between again and at load we are connecting a C5. Okay, in this we are measuring the output voltage at okay, this is the basic difference of ratio detector as well as Foster-Seeley discriminator. Okay, in this it provide high output, it provide a low output. Both are used in FM radio receivers. It is used in amplitude limiting audio signals also, mainly ratio detector. It does not require emitter. Okay, 80% of the circuit is same as per Foster-Seeley as ratio detector. Okay.